Yep, review number 4. For your quiz tomorrow. Right. 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 Nice language. Right. Pansy, are you going to try to pass this class this year? Yes or no? Do you think you better do something? You too? What do you think you should do? Huh? You're done with the review? Want the quiz? I'm confused. Did you do the review? Huh? Did you what? Did you do the review? No, you didn't. You. That's what you did. Okay, I would do the review. What I have to do is ask. You're welcome. Sorry, my toss didn't work that well. Pardon? No. No, you got to come in before or after school for that. Is this blurry to you or to me? Worse? So much for autofocus, huh? Yeah, but I don't know how to use it. Jeez. I don't know how to do manual. Isn't that awful? Oh, how about that? Still blurry? How about if I move closer? But I'm recording. Does that work? Hey, number 1A, I'll do the A's. Yeah, how many of you are still need factoring grades? Do you need a factoring grade? Oh, that's not horrible. Hey, 1A, what do I have there? Determine what you have. Well, I'm going to use my chart. Can I factor out any common terms? Well, nope. What type of polynomial do I have? Do I have 2 terms, 3 terms, or 4 terms? I have 2 terms. Is it a difference of squares? Well, I have 27 and 8. Let's see, do I have a 27 or 8 in squares? Nope. I do have a 27 and 8 in cubes, so I know that it is a sum of cubes. See how we use that chart? That's why I gave it to you. That's why I let you use it on quizzes. Okay, so I have a sum of cubes. I need an A, and I need my B, right? Okay, how do I write 27 as a cube? If I don't know, yeah, I can put in my calculator, take the cube root. And so get your calculators. Let's see, it's the math button. And here's my cube root, number 4. So cube root of 27, enter, is 3. So 27, my friends, is 3 cubed. I have x cubed. And what's 8? What do I cube to get 8? 2. 2 times 2 times 2. So 2 cubed. So what's my a? The base is being cubed. What's my a? 3x, right? 3x is being cubed. My base for b? All you have to do is put it in the formula now. Okay? I have sum of cubes, and here's my factor form. A plus b. So a plus b is 3x plus 2. A squared. What's 3x squared? Be careful. 9x. We're squaring it. 9x squared. Okay. All right, a times b. What's a times b? There's a minus sign in the formula. 3x times what? A times b. 2. 3x times 2. 6x. Okay, and then I have a plus sign in the formula. What's 2 squared? There it is. Can't get much easier than that. How about 2a? Now, a lot of you are missing that. Okay. Step 1. Can I factor out any common terms? No. Yes, we can. There's an x, at least an x in there in each term, right? Okay, so I'm going to factor out an x. Now, I'm looking. No phones, no phones, I'm talking. No phones, phones. No phones. Oh, gee, I wonder why. Okay, so forget it. Play on your phone. Yeah, forget it. Don't worry about learning how to do it. Just forget it and play on your phone. Doorknob. Okay. Okay. Now I'm looking at the 7 and the 112. I'm not that good with my multiplication tables, but I'm going to give it a shot. I'm going to take 112 and divide it by 7 in my calculator. See what happens. I get 16. How about that? So if I factor out a 7, I get x to the 4th minus 16, right? Because I'm taking off that x. All right. Anything else I can factor out? No. Okay, so I go down. What type of polynomial do I have? Do I have 2 terms? Do I have 3 terms? Or do I have 4 terms? How many terms do I have? 2. 2. Just shout it out when it comes to you, okay? So I have 2 terms. I'm now looking at my parentheses because this is kind of like actually it's my slope, or 0. Okay, so I'm looking at my x to the 4th minus 16 in 2 terms. Is it a difference of squares? Is x to the 4th a squared? Can I write it as a squared? How? X to the 2nd squared. I can write that as a squared. I can. Yeah. Okay, what about 16? Is that a square? Well, if I look down at my perfect squares here, hey, look, 16 is a perfect square. Okay, how do I write 16 as a square? That's right, 4 squared. Okay, now, what's my A? My A, no, I'm kind of ignoring the 7x for now. What's my A? X squared. What's my B? 4. Okay, yes, 4 is being squared. Okay, I have my 7x. I'm just going to bring down. I'm not doing much to that. I have a difference of squares, right? It's a plus b, a minus b. What's my a again? X squared plus b is my 4. X squared minus 4. Am I done? No, why? I could still factor it, right? I could still, yeah, think of it as simplification. What do I have? I have 2 terms here, right? Is that a difference of squares? No. I have 2 terms here. Is that a difference of squares? Yes, it is. Okay. How do I know that? Because, well, if I don't, I can look at my chart. Hey, 4 is a perfect square. Yeah, but it's not a difference. This is a sum. Is there a sum of squares on here? Is there a sum of squares on your chart? No. There's a difference of squares. We can factor that, but there's no sum of squares on it. You got a sum of cubes, but I don't have a sum of squares. What? How are you confused? What are you confused about? How do I determine what? There's with a plus sign. That's got a plus sign. That's a sum. If it has a plus sign, it's a sum. If it's a minus, it's a difference. If I had 4x squared, my a would be 2x. That? All right. Oh, I can still go farther with this because I have a difference of squares. X squared and 4 are both perfect squares. What's my a here? X. And what's my, no, not x squared. Up here it was x squared because I had x to the 4th. Here it's just x. Okay, my b is what? Careful. It'd be the numbers being squared to get 4. 2. This 4 is 2 squared. Right? Follow me, Kayla? It didn't sound too convincing. Okay, the base being squared is 2. Okay. So, nothing I can do with the 7x. This is actually an imaginary number system, but we're not going to worry about it right now. X squared plus 4 does not have real solutions. Okay, so I have a squared minus, I'm sorry, a plus b, a minus b. So my a is x, x plus minus, and my b 2, 2. This is my answer. Yes. But remember, I'm an easy teacher. I take your highest grade for factoring. This is like the fourth time they're being quizzed for factoring. Yeah, if you got a 4 in the first time, you should have skipped or not worried so much, not studied, put your focus on the new stuff that we did, right? What's nice about taking the highest grade. Number 3A. 3a. Can I factor out anything out of all terms? No. How many terms? In fact, how many terms do I have? 4. So I can't take out any common terms. I have 4 terms. I have to factor by grouping, right? 4 terms, factor by grouping. What does it mean to group? Group, 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 parentheses. Okay, I made. What can I take out of this first group? I can take out an x. Anything else? A 4. Okay, 4x cubed divided by 4x. Leaves me with an x squared. 8x. Oh, actually, I can take out a squared. I didn't see that square. Okay. So that leaves me with x to the first. Stop playing with your loop. 8x squared divided by 4x squared leaves me with a 2, right? 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 Okay, I'm taking 8x squared and I'm dividing it by 4x squared. These cancel. 8 divided by 4 is 2. Okay, what can I take out of negative 5x and negative 10? Negative 5. Okay, negative 5x divided by negative 5 leaves me with x. Negative 10 divided by negative 5. Positive 2, right? The whole idea here is to get the same quantity, the same group, more or less, right? When you get the same group, you're kind of like undistributing it, right? X plus 2. And what do I have left over? My 4x squared and the minus 5. Now be careful. Make sure you can't factor that any further. You can't. That's my common factor between in this group. Okay, if I have, let me ask you this. If I have 2x 2x plus 4, what do I take out of each one of them? The 2, right? So I'm taking a 2 out here, and I'm multiplying it by x plus 2, right? Well, I'm doing the same thing here. Instead of a 2, I've got x plus 2. Okay. All right, 4a. How do you determine how many solutions a polynomial has? No. Look at the highest degree, right? Fundamental theorem of algebra. Highest degree. What? Can I what?
Are those questions on the quiz?
Okay.
Are those like
Yes. One example of a polynomial with 4 solutions. How about x to the 4th? How about x plus 1 times x plus 2 times x plus 3 times x plus 4? Anything with x to the 4th. 4th, right? Okay, 5a. 5a. Now, it says we have a lot to do with this. Using your calculator, find all rational zeros. How many zeros do I have in this polynomial 5a? How many zeros do I have in x cubed minus x squared plus 25x minus 25? 3. 3 zeros. Because of the highest degree. Okay? Can I blow this up a little bit? Are you done? Okay, zeros from the calculator. So we need to find 1 0 from the calculator, at least, because I can factor and get the other zeros from a quadratic, right? Put the phones away, dorks. Yeah. Okay, so my y equals, I have x cubed minus x squared plus 25x minus 25. I'm going to graph it. I need one of the zeros, x-intercepts, roots, solutions, however you want to call it. And lo and behold, it looks like I have an x-intercept at 1, 0, right? Or 1 would be one of my solutions or zeros. I'm going to double check. I know x-intercepts have a y value of 0, right? I'm gonna try the cheater's way first. I'm gonna look at my chart. Okay, I'm gonna see my chart. Here's my graph. Okay, it looks like it's at 1. I'm going. Yeah, it's a common. That's my x-intercept. So I'm gonna look at my chart, and lo and behold, yes, 1, 0 is a point that is a solution. Okay, so I have 1, 0. So one of my zeros is 1. Yes, that's cheater's way. Otherwise, I got to use second trace, pick 0, left bound, right bound, that type of thing. Okay. All right. So I have a 0. So I'm going to use synthetic division to knock this down from a cube root, a cubic, to a quadratic where I can factor it myself. Then I can find the other 2 zeros, right? With me? Yeah. Okay, so my coefficients, 1, -1, 25, -25. Bring down the first one. 1 times 1 is plus -1. 0 times 1 is plus 25. 25 times 1 plus -25. I better get a 0 for my last one, okay? Because we're knocking this down to a squared, right? So this is supposed to be a 0. So I end up with x squared plus 0x. I'm going to leave that one out. Huh? Yeah, I don't have to put the 0 in there. And then plus 25. Now, I'm going to set this equal to 0 because I can factor quadratics. I can find the other 2 zeros. I'm going to set it equal to 0. Now, is this a difference of squares? No, it is not a difference of squares. It's a sum of squares. And again, if you look on your pink chart, there's no such formula for sum of squares. If it was a minus sign, I could do it. So I'm just going to solve this the way it is. I'm going to subtract 25 from each side. X squared equals -25. Square root to get rid of the power of 2. 5x equals, what's the square root of -25? 5, well, plus or minus, right? You can't square root a negative number. Plus or minus 5. How do I get rid of that square root of -1? The I. Okay, square root of -1 is I. Square root of -1 is I. So my answer here, my 3 zeros, I have 1 plus or minus 5i. Because that gives me 2 of them. I have a positive 5i, negative 5i. There's 2 imaginary solutions. And then my real solution is 1. So here's my 3 solutions. Okay? These aren't easy. are not easy. These are kind of difficult. Imagine if we made you do this long division. Okay, 6a. 2x cubed minus 8x squared plus 2x plus 5. Put it in your calculator. 2x squared minus 8x squared, which would be cubed, plus 2x plus 5. Graph it and find my x-intercepts. Like they're going to be decimals. So I'm going to second trace. Right? First 0, hit enter. Left bound, my cursor to the left, enter. Cursor to the right, enter. My first 0 is 6.34, negative 6, comma 0. Second 0, second trace 0. To the left bound, enter. Right bound, enter, enter. Second 0 is 1.12. 0. Third 0, second trace 0. Left bound, enter. Right bound, enter, enter. And my third one's at 3.10. Okay, max. Let's find this max. Second trace, max. Left bound, left to the max. Enter, right to the max. Enter, enter again. Max is at 0.13. And my Y value is 5. Minimum, second trace, minimum, left bound, left to this point, enter, right to that point, enter, enter again, my minimum, 2.54, negative 8.76. Okay, 5 points to put on my plot to my graph to help me. See, I've got negative 6.3, so a little bit over negative 6, 0. 1.120, so a little bit over 1, and 3.5, 0. 3.5, 0. Max, 0.13, so just a little bit over, up 5. Bit over 5, that's my max. My min, 2.5. Negative 8, almost 9. This should be negative. Oh, negative 0.634. Coming up from the bottom, my max, turn, hit my min, turn, and there's my graph. Okay, where's it increasing? The increasing starts at negative infinity, goes up to my y value of my max. So it increases from negative infinity up to my y value of my max, which is 5.13. Increasing and decreasing, always use parentheses. And then decreasing, see, decreases from a y value at my max to the y value of my min. So y value of my max, which is 5.3, comma, y value of my max to my y value of my min, which is negative 8.76. And then it goes back to increasing with the y value of my min, and it goes up to positive. Y value of my min, negative 8.6. End behavior. As soon as I see end behavior, here's my template. Fill in the blanks. This is left on my x-axis, so this goes to negative infinity. This is right on my x-axis, positive infinity. As my x goes to negative infinity, start at my origin. As x goes to negative infinity, my y goes to negative infinity. As my x goes to the right, my graph goes to positive. That's it for 6A. 7A. Graph of exponential growth and decay. So we have to identify the horizontal asymptote, find domain, range, and behavior. So I have domain, horizontal asymptote, domain, range, and behavior. Right away, I need to write my template. I will put in my left and right. Actually, they put it on here for, but that's okay. I'll write it out. Growth or decay. It's growth because my b is less than 1, or my b is a fraction between 0 and 1. Horizontal asymptote, well, my shift, my transformations, or my shifts, is down 5. That's it. I only have the one shift. So normally, I would have my asymptote at y equals 0, the x-axis, but since I have to go down 5, my asymptote is going to be y equals negative 5, because down. Domain for all our growth and decays Oh, our B is a fraction. This is a decay. Decay. If it's greater than 1, it'd be growth. Back out. So K, because it's a fraction between 0 and 1. Domain for all our growth and decays, negative infinity. Our range is going to be our asymptote value, -5. And since it's decay, it's going to go up to positive infinity. Doesn't reflect on the axis. As my x goes to the left, my y is going to go to positive infinity. As it goes to the right, since it's decay, it's going to go to my -5. Graph it, get some points. One, two, -7. Much better. You're welcome. And then it's going to try to example of growth. How can you tell if it's growth or decay? Again, if my b is greater than 1, if it's a fraction between 0 and 1, okay. Watch out for negative exponents. Remember, you have to flip, make it a positive, so this is actually decay, because b is between. Flip this. 3 have the x growth. Even though it's a fraction, it's still greater than 1. It's 1.5. 1/5, flip it, 5/1 to the x, so my b greater than 1. Okay, transformations of growth and decay. I look at the exponent, and then I look what's happening outside that term. So inside the term, right, remember it's the opposite sign. Outside, it's the same, down 2. Going to be left 7, 9. C. Consider the function f of x equals 7x. Write the new function g of x that has been shifted right 5. Shift right 5, so opposite sign and up